Hello dear students, today we are going to discuss what is gauche conformation and anti-conformation. Remember that these are also the types of Newman's projection. Now, what is gauche conformation? In order to understand this, we must add up a bulky group to our organic structure. For example, if we take the example of propane, we should draw a Levy structure of propane first, then we will select our bond of interest. Let's suppose in this case the bond of interest is here, which is mentioned by this bold line. Now this will be our bond of interest. Now the projection will be drawn around this bond of interest. So this is carbon number 1, carbon number 2, and carbon number 3. So we are assuming that C1 is proximal and C2 is distal to the C1. So let's draw its Newman's projection. Here we are drawing C1 and we have to draw C2. For C2, what we're going to do is that we can draw two hydrogen atom and one full methyl group. So for C2, here we have methyl group and hydrogen atom added. Now this conformation is at 0 degrees because there is no particular angle of rotation between CH3 and hydrogen atom, and same case for other dihedral bonds. So they are also superimposable. We have named it as an eclipse form. Now what is gauche? The gauche conformation takes place when we will rotate the bulky group either to the clockwise direction or to the counterclockwise direction. The angle should be either theta is equal to 60 degrees or theta is equal to minus 60 degrees. Remember that this is also an staggered conformation and it only happens when there is one bulky group attached. Let's draw at theta is equal to 60 degrees. I am going to mention the bulky group with this bold line. Now, as you can see that it is a staggered conformation. Let's draw at theta is equal to minus 60 degrees, or we can say that at 300 degrees. Now the conformation will look like this. Here the bulky group will be at theta is equal to minus 60 degrees. Here, and we will have hydrogen atom attached here. So both of these conformations are gauche conformations. You can define the gauche conformation as the conformation in which the dihedral bonds are in staggered form where the bulky group is directed at an angle theta is equal to 60 degrees, or theta is equal to minus 60 degrees, or 300 degrees. Now these angles should be mentioned in definition, and it's necessary. Let's take a look at anti-conformation. In anti-conformation, now concentrate that we are rotating this CH3 group, and we are rotating this CH3 group at 180 degrees. Let's draw the anti-conformation. Now, the anti-conformation will look like this. This is our front carbon that is attached to 3 hydrogen atom, and here we have drawn the backward carbon, and here we have mentioned our bulky group in the form of methyl, and we have hydrogen atom here. If you look closely, it is also a staggered conformation. And the angle is 180 degree between here and here. Now you have to identify here I have drawn three structures, and I am going to label it as A, B, and C. Now the question is, which of the following is Gauche conformation or anti-conformation? You are correct. The first one is Gauche conformation at theta is equal to 60 degrees. The second one is also Gauche, but theta is equal to minus 60 degrees. The third one is anti, but theta is equal to 180 degrees. Now the question is, which of the following will be more stable? The stability criteria for these A and B structures will remain the same, but the stability criteria will be different because the bulky groups are at a maximum distance far apart. So we would say that Due to less steric hindrance and van der Waals repulsion, anti-conformation will be relatively more stable than these two Gauche conformations. Now you came to know that there is also a stability difference between staggered conformations as well. Thanks for watching. If this was informative, please like, subscribe, and click the bell icon. And if you are one of my students, then you should definitely subscribe. You can also take lectures on desired topic by just commenting your topic